This is example number 1 for simple harmonic motion. It says a hummingbird beats its wings up and down with a frequency of 80 hertz. They want to know what is the period of the hummingbird's flaps. This one's really pretty simple. You know your frequency is equal to 80 hertz. And if you remember from a couple units ago, the period is equal to 1 over the frequency. We just plug everything in, 1 over 80. And that will give you an answer of 0.0125 seconds. Make sure you don't leave it in fraction form. In physics, we want to go ahead and use the decimal equivalent. It makes it a little bit easier to understand. So that is example number 1. Let's look at example number 2. For example number 2, it says in anticipation of her first game, Alicia pulls back the handle of a pinball machine a distance of 5 centimeters. The force constant of the spring handle is 200 newtons per meter. How much force must Alicia exert? First thing we need to do is take that 5 centimeters and we need to convert that into meters. We know that there are 100 centimeters in every meter, so the centimeters cross off, the meters then will go up to the top, and so this would be 0.05 meters for your distance. The spring constant is equal to 200 newtons per meter. And we already know the distance is 0.05 meters. The equation we will use is F is equal to K times X, where F is the force of the spring, K is the spring constant, and X is either the compression or the extension of the spring. We can plug everything in now. This is 200 newtons per meter, and we'll multiply that times the 0.05 meters. Notice the meters cross off. 200 times 0.05 will give you the final answer of 10 newtons, and that is simple harmonic motion example number 2. On to number 3. For number 3, we have Bianca standing on a bathroom scale. The force constant of the scale is 220 newtons per meter, so this K is equal to 220 newtons per meter. We also know that when she stands on that bathroom scale, it does vibrate back and forth. So this is the old style scale that has a dial on it, and that dial will move back and forth until it actually finds your weight, and then it'll stop there. Her mass is equal to 180 kilograms. For a spring, if you remember, if I have a spring that's like this, and if I pull down on that spring will oscillate back and forth until it comes to equilibrium. They want to know what is the period of vibration, T, knowing that the spring constant is 220 and the mass is 180. So here the period of vibration is equal to 2 times pi times the square root of m over k. And this is the period of a spring, which is pretty easy to do. So T is going to be equal to 2 times pi times the square root of the mass, which is 180, divided by 220, which is the spring constant. And we find out that our spring has a period of about 5.7 seconds. That is simple harmonic motion example number 3. And that is the end of the first 3 examples for this section.